So let's compare the disk and the shell methods. Well, actually, the disk and washer method and the shell method, because the disk and washer method are basically the same method. With the disk method, when you have your axis of rotation here, so if it's a vertical axis of rotation, your rectangle is always perpendicular to that axis of rotation, right? And so that means that it locks in. If you know you're using the disk washer method, it will lock in for you whether you're doing dy or dx. Oh, right here. I linked it right there. Sorry, I didn't see that up there. I wasn't looking. Okay, so if you know your axis of rotation is horizontal in the disk washer method, you will be using dx. If it's vertical in the disk washer method, you'll be using dy. Right? It's always perpendicular. So the rectangle is perpendicular to the axis of rotation in disk washer. Right? As long as you know that, then you can't mess it up, right? Because you just remember it's perpendicular to the axis of rotation. I'm cutting across this item, okay? So you're hacking into it across, you're doing it crossways, and therefore it's perpendicular. In the shell method, when you have a vertical axis of rotation, then it's parallel to that axis of rotation. So it goes this way. So if you have a vertical axis of rotation, that means that you're doing dx. And if you have a horizontal axis of rotation, like this, then that rectangle is parallel, which means I'm using dy, like that. So once you know which method you're going to use, then you can lock in this way, because once you know your axes, then your rectangle will be parallel in the shell method, but perpendicular in the disk and washer method. Okay. That's the key difference between the two. Perpendicular for disk washer, parallel for shell method. And then once you have those differences, then the formulas fall from there. Now remember, you don't really have to memorize those formulas because they're on your formula sheet, but you have to know how to use them and what they mean. So when you're looking at your formula sheet, if you want to see, the shell method, it's right here, but you have to know which one of these two to use, and you get locked in based on what kind of axis of rotation you have. If you have a horizontal axis of rotation, it will be dy. If you have a vertical axis of rotation, it'll be dx in the shell method. And then in the disk washer method, it's the opposite. Now, sometimes one of these methods is preferable to the other. Students tend to think that the washer method's always easier. That's not true. Actually, the shell method is often easier when you're rotating around lines that are not the axes. Not always, I don't want to say always, but it's often easier when your axis of rotation is not the x nor y axes. All right, so let's do a problem that compares the two methods, just to remind ourselves of everything that we've learned. Okay, so we're going to take one region and we're going to do this twice. Same region, two methods. So we're going to take this zone right here, this region, and we're going to use the shell method on this one. So the shell method, we are going to find the volume of this solid. All right, shell method, we're rotating around the line x equals -1/2. See right there? So that's not actually drawn on the picture, so I'm going to draw it in over here. there's a line over here that is x equals negative 1/2. That is my axis of rotation. And you can tell from over here in the problem. All right, so I'm going to rotate around that axis of rotation. If I'm going to use the shell method, then my rectangle will be parallel to that axis of rotation. Period, the end. All right, that means that I'm going to do this dx, because those are differences in x's. That's from left to right for that rectangle, so that's dx. Okay. All right, so then let's think. The volume is equal to, once I know it's dx, I know I'm locked in. It's 2 pi, the integral from a to b, r of x, f of x minus g of x dx. I am totally locked in. That'll be the radius, that'll be the length. Okay, now, both of those are going to be tricky to find. What is not tricky to find is actually a and b. I can tell right here is my start. I start at x equals a, I end at x equals b. Those are the x values that begin and end my shaded region. So that's actually quite easy. So I've got a and b all done. All right, well, let's begin with the radius. Why not? Got to start somewhere. All right, so the radius is, let's see, this bit right here plus this bit right here. Those two together form the radius. Right? Okay, now how far is this? This distance right here, since this is x equals negative half, that's a half. Distances can't be negative, so it's a half. And then this distance right here is the distance from 0 out to that value, but that's x. I mean, that's what x measures for us. The distance from 0 out to wherever this vertical line is. So that's x. So that means that the radius is a half plus x. Okay. So I actually know right now, I'm going to take the integral from 0 to 1. I now know my radius is a half plus x, or x plus a half, I guess. A half plus x is how I thought of it, but it doesn't really make any difference. All right, so x plus a half plus x, whatever you like. Now, the length. The length is this distance right here, right? That would be the length. All right, how much is that? Well, that's this whole distance, which is 1, minus this distance, which is that curve, which was the square root of x. So when I want that length, what I want is the outer function minus the inner function. So I want 1, because these are functions in x. So the outer, the farther one away in terms of x is 1. 1, so that's 1, minus the square root of x. Actually, I'm going to rewrite that. I'm going to rewrite that as x to the half. I'm about to take an integral here. Nobody wants any part of a square root when you're trying to take an integral. That's just crazy town, right? Now, see if you can visualize it. 1, take away the square root part, because the square root of x is the distance from here to here, right? So 1 is the whole thing. Square root of x is that part. So the length is the leftover. The length is 1, take away the square root of x. So right here, the upper function minus the lower function. All right, dx. Lovely. Now that we're here, we can find this integral, no problem. So 2 pi, integral from 0 to 1. Let's see, this is x plus a half minus 1. Yeah, so x plus a half, I did it that way, minus x to the third, so x to the 3 halves, because x times x to the 1 half is x to the 3 halves, and then minus a half x to the 1 half. It didn't really matter what order I went in. So dx, just as long as I get all 4 of them there. So I didn't actually go in the first outers integers last formula, sorry about that. All right, so then this is 2 pi, that's 1/2 x squared plus 1/2 x minus 2/5 x to the 5 halves. And then the only one that's even remotely got any brain power to it is a half times 2/3 times x to the 3 halves. Like that. And we're going to take it from 0 to 1. Hooray, yet again, we don't have to worry about the 0. So this is 2 pi times a half plus a half minus 2/5 minus, oh, the 2's here cancel. So minus a third. Which is 2 pi times 4 over 15, which is 8 pi over 15 meters cubed. And for a decimal, just to prove it, whoop, wrong, I pressed on the wrong thing here. All right, so there you have it. So there's the original function that I put in. I actually used f of x, and it was 8 pi over 15, which is 1.6755. All right, that's the shell method. Now we're going to do the exact same problem, exact same one, but we're going to use the disk washer method. Okay? All right, so back I go. Same problem. I have my axis of rotation over here at x equals -1/2. Right, that is still my axis of rotation. So I'm still spinning around this. It's literally the same problem. So I should get the same answer. Okay, now this curve is y equals the square root of x. So we'll have to keep in mind that, well, we'll just keep that in mind. All right, now remember, if that's my axis of rotation, for the disk washer method, I go perpendicular to my axis of rotation like this. So I'm going to be perpendicular to the axis of rotation. So then this is dy. So now I'm going to lock in. I know that I want to do this problem with dy, so I go back to my washer method with dy, and I write that formula right there. So I'm going to say the volume is equal to pi times the integral from c to d of r of y squared minus little r of y squared dy. Once I know it's dy, I am locked in stone, right, because I'm using the washer method. Okay, so let's think here. I got to think about a lot of things. Everything's with respect to y. So my c and my d are actually also locked in. It's 0 here, that's my start, and 1 right here, that's my end. So it's 0 and 1 again, right? So that's fine. So this is pi times the integral from 0 to 1. Just putting those in there. Now, the radiuses. Remember, this is like you're cutting across it and you're forming this kind of like DVD kind of, well, it's a washer. So I need to know my outer and my inner radius. Now, the outer radius, well, we kind of already found it a little bit. It's this bit right here. Well, let me put it this way. The outer radius is this distance right here. That's your outer radius, right? Because you're swinging it around this way. Now, what is that? Well, this distance right here is a half, right? That's set in stone, right? That just is a half. So then this outer radius would be a half plus whatever this part is. But this part must be the function itself. But that function's not in terms of y. I need everything in terms of y. So I'll make a little note. So note. If y is equal to the square root of x, that means x is equal to y squared, right? That's what I need, because y squared is the distance from here to here, and a half is that distance. So the radius is a half plus that y squared. This bit plus that extra bit. That makes my radius. So my r of y is y squared plus a half. So I'm going to put that in there, and then I'm going to square it, if I can find my marker. So it's that one squared minus, now I need another one squared. Luckily the other one's actually easier, right? So remember what you're doing. You're cutting across this thing. So you're forming kind of a DVD shape. So you know that from the axis of rotation out is a half plus, right? So it's like a little bit of a half right there from here, from the axis of rotation to that edge is a half. And then the rest of it is the function. Then what's the inner radius? Well, it's the half, right? This actually is r of y. R of y is that little bit that's being cored out. So this is actually just a half. So this problem actually, I think, is a little bit easier in the washer method. It happens. Okay, so this is pi. I promise there are some that are easier with shell. It just, it just depends on the problem, depends on the setup. So 0 to 1. Now, what's this part? If I square this, that's y to the fourth plus a half y squared, another half y squared makes y squared, plus 1/4, right there, for that piece, minus, and then a half squared is another fourth, so that's minus a fourth back there, dy. Okay, oh, that bothers me. I'm going to make that orange. Okay, so dy, but the fourth and the minus a fourth are going to cancel, right? They're going to be gone. So that leaves me just y to the fourth plus y squared. This problem is really simple. So this is pi times the integral, well, I'll just take the integral. It's 1/5 y to the fifth plus 1/3 y to the third from 0 to 1, which is pi times a fifth plus a third, which is 3/15 plus 5/15, which lo and behold makes 8 pi over 15, which I can't remember the decimal. I think it's 1.6755. So it's good to know if you have to do one method, you can always check yourself with the other method, because both methods should work. So we did it with both the shell and the washer. So with the shell method, we found 8 pi over 15. It was 2 pi times x plus a half times 1 minus f of x from 0 to 1. When we do the washer method, it runs perpendicular. The rectangle is perpendicular to the axis of rotation. And there you can see y squared plus a half squared minus a half squared. And sure enough, we get the same answer, 8 pi over 15. So both methods will work. So then you just have to use whichever one's more appropriate, or whichever one you feel more comfortable with, or whichever one is being asked for in the particular problem. But you can always check yourself with the other method, even if one method is being asked for. Another option is if you find yourself getting stuck, like if it doesn't tell you which method to use and you have a choice, you can try one method, see if you're understanding it. If you're struggling, then stop and try the other method. See if that goes better for you.